Yes. Good evening, dear students. So, we have completed in the previous session the chapter aldehyde ketones and carboxylic acid. Okay, so today we are going to start with a new topic. So, the last topic in the organic chemistry, that is amines. Okay. So this is the last topic in the organic chemistry, that is amines, that is compounds containing nitrogen atom. Okay, so amines. Okay, how do you represent amines? Amines, what is the functional group for amines? It is NH2, right? NH2. So NH2 is the functional group for amines, right? So this particular chapter, amines, is for 8 marks. Okay, so the total marks allotted for this particular chapter is 8 marks. Okay, so in 8 marks, you'll be getting 1 mark, 3 questions. Okay, you'll be getting 1 mark, 3 questions, and 5 mark, 1 question. So long type of question is asked. Okay, one long type of question is asked for 5 marks. So 3 1 mark question and 1 5 marks question. Okay, so 3 questions, 1 mark will be for your this only what MCQ part. Okay, MCQ part will be for 3 marks. So 3 marks, 3 questions, 1 mark from that. Okay, and 5 mark directly 1 long question. So we'll start with the MCQs first. Okay, so in this particular chapter, okay, amines. What are amines? So amines are the compounds which consist of a nitrogen atom. Okay, so it is NH2. So how are the amines classified? So amines are classified as primary amines, secondary amines, and tertiary amines. So primary amines, they are represented as RNH2. Okay, so when the when the amine group is attached to only one alkyl or aryl group, okay, then they are called as primary amine. Then second is secondary amine. Okay, what are secondary amine? Secondary amines are your NH group is attached to two alkyl or aryl group. Okay, so it is a secondary amine. Then third is a tertiary amine. What do you mean by tertiary amine? Tertiary amine is all the hydrogen atoms are replaced by alkyl or the aryl group here. Okay, so you can see here, right? So this is a tertiary amine. So these are the classification of amines. Okay, so these are the classification of amines. Understood? Okay. Okay, so this is the classification of amines. Now, so in this particular chapter, you have also studied about the preparation of amines, right? You have studied the different preparation of amines. So which are the important preparations you have studied from this particular chapter? The first is Gabriel thalamide synthesis. First is what? Gabriel thalamide synthesis. Okay, so this particular synthesis you have studied from this particular chapter, that is very important, Gabriel thalamide synthesis, right? So from the thalamide you are synthesizing your amide. Okay, so from the thalamide. Then second, you have studied from this particular chapter, the preparation is Hoffman bromamide degradation reaction. Okay, Hoffman's bromamide degradation reaction. Okay, so this particular reaction is also very important, where we can prepare the amines from this method. Next is by ammonolysis. Okay, by ammonolysis also you have studied the preparation of amines. Then by reduction of amides. Okay, by reduction of amides you can prepare the amines. Okay, so this is also, so these are the preparations, important preparation. Then from nitriles. Okay, from nitriles you can, so from nitriles by reduction. So from nitriles also, by doing reduction on nitriles, you can prepare the amine. So what are nitriles? C triple bond N. Okay, C triple bond N is nothing but your nitriles. Okay, so nitriles, if you do reduction on nitriles, then what you get? Reduction on nitriles, you get this what? Amines. Okay, so this is also a preparation. Then by reduction of nitro groups, by reduction of nitro groups. So what you can do in nitro groups, so nitro group, if you do reduction, it will be converted into amines. Okay. So these are the important preparations you might have studied from this particular chapter, that is amines, right? Then next, the important things you might have studied from this particular reaction is chemical reactions. Okay, the different chemical reactions from this particular chapter. Okay, the first chemical reaction is carbalamine reaction. Okay, carbalamine reaction. Then you might have also studied about acetylation and benzoylation, right? You acetylation and benzoylation. Then the very important, okay, very important is your what? Uh, this what? Diazotization reaction. What is diazotization reactions? So diazotization reactions, we are doing it on amines. Okay, we are taking a primary amine, then we are treating it with sodium nitrate solution in the presence of hydrochloric acid. What you get? You get NaNO3. Okay, NaNO3 plus HCl. So this is produced, okay, nitrous acid and hydrochloric acid at a temperature of 0 to 5 degrees Celsius, you get a diazonium salt. Okay, you get a diazonium salt. So this particular reaction is very, very important in case of your amines. Okay, so the chemical reaction, that is diazotization. Then is Hinsberg reaction. Okay, Hinsberg reaction. So Hinsberg reagent is also very important. You might have studied from this particular chapter. Then the reaction with bromine water. Okay, bromine water is a mild oxidizing agent. Okay, bromine water is a mild oxidizing agent. So how the reaction takes place. So these all things we are going to cover as in how we are going to cover the questions. Okay, so these things will be covered. So just I'm giving you a recap. Okay, what all you might have studied from this particular chapter. Okay, then you might have also studied about the nitration reaction. Okay, that is a indirect method. So nitration reaction on amines. Okay, then the next one is with concentrated H2SO4, how amines react with concentrated hydrochloric acid. Okay, so these are the various chemical reaction. Then the important part from this particular chapter is diazonium salts. Okay, diazonium salt is very important. What topic from amines? Okay, so that is the preparation of diazotization. How the preparation of diazotization takes place. Okay, then there are chemical properties. Okay, the various chemical properties of diazonium salt. That is, the first one is Sand-Meier's reaction. Okay, Sand-Meier's reaction. So these name reactions are very important. Okay, you might have studied this. Okay, after hearing the name, you can recall the things. Okay, so Sand-Meier's reaction, then Gattermann-Koch reaction. Gattermann-Koch reaction, one of the very important name reaction, that is Gattermann-Koch reaction. Then the third is coupling reaction. Okay, the coupling reaction. So these are the reactions, okay, chemical reactions in case of your diazonium salt. Then the reaction of diazonium salt with your potassium iodide. Okay, then hydrofluorates, okay, borofluorates and ethanol. Okay, that is a alcohol, ethanol and water. So these are the various chemical reactions you might have studied from this particular chapter. Okay, so without wasting any time, so we'll start with the MCQs now. Okay, is it clear? So these are the things you might have studied from this particular. Okay, so these are the things, okay, which are there from this particular chapter. Okay, fine. Okay. Okay. So moving forward, so we'll start with the MCQs now. Just a second, I'll zoom this so that you will be able to read it. Okay. Okay, fine. Just a second. Okay. So we'll start with the MCQs now. Okay. So the first question, you can read out the first question. So the first question is, the gas liberated when ethyl amine reacted with HNO2, okay, at low temperature is. So which is a gas which is liberated when ethyl amine reacts with, okay, HNO2 at low temperature. A, ammonia, B, N2, then C, H2, and D, O2. Yes, try to answer. The gas liberated when ethylamine reacted with HNO2 at low temperature is. Okay, Priyanka has answered. What about others? Okay, what about others? Only Priyanka have answered. Yes. So see the reaction. So ethylamine. Okay, what is ethylamine? It is CH3. Okay, CH3, CH2, NH2. Okay, ethylamine, when it reacts with, what is this? It is nitrous acid. Okay, how this nitrous acid is formed? When NaNO2, okay, when NaNO2 reacts with your HCl, sodium nitrate, when it reacts with HCl, it forms HNO2. It forms what? HNO2 is formed. When sodium nitrate reacts with hydrochloric acid, and what it forms? It forms a disonium salt. What it forms? Disonium salt is formed, that is CH3, CH2, then N, triple bond N. Okay, N plus, N minus, C minus. Okay, so this is a ethyl disonium salt is formed. What is formed? Ethyl disonium salt is formed. Ethyl disonium salt is formed. This ethyl disonium salt, okay, what happens when ethyl disonium salt is formed? This further, okay, there will be liberation of water molecule and it forms CH3, sorry, just a second, CH3, then CH2 and OH plus HCl, okay, with the liberation of N2 gas. So what is liberated? N2 gas is liberated. Okay, this nitrous acid, you can see here, okay, this particular N triple bond N. Okay, you can see this N triple bond N, right? So this N triple bond N will be given out in the form of N2 gas. So what is the answer? It is B. What is the answer? Answer is B. Okay, the answer is B. Is it clear? So ethylamine, when it reacts with nitrous acid, this is a nitrous acid. So how this nitrous acid is formed? When sodium nitrate reacts with hydrochloric acid. What is the intermediate which is formed? Intermediate formed is a disonium salt. Okay, the intermediate formed is a disonium salt. So ethyl disonium salt is produced. So there will be loss of water molecules. So when there will be loss of water molecule, alcohol is formed. Alcohol. So your amine is converted into alcohol with the liberation of nitrogen gas. With the liberation of nitrogen gas. Is it clear? Okay. So we will move further. Next question. So the answer is B. Okay. Next question. The amine which cannot be prepared by Gabriel thalamide synthesis is. The amine which cannot be prepared by Gabriel thalamide synthesis is A. Methylamine, B. ethanamine, C. aniline, and D. propylamine. Yes, students, please answer. So you can give your answers in the chat box. Okay. So you can give your answers in the chat box. So in the chat box, you can give the answer. Okay. Priyanka has answered. Priyanka has answered as C option. Okay. What about others? What about others? Gabriel thalamide synthesis. Okay. What in Gabriel thalamide synthesis we can prepare only what? Only we can prepare primary aliphatic amines. Okay. We can prepare primary aliphatic amines. Okay. Now methanamine. So this is a aliphatic amine. Ethanamine is a aliphatic amine. Propanamine is a aliphatic amine. Aniline. What is aniline? Aniline is a aromatic amine. Okay. So aromatic amines cannot be prepared by Gabriel thalamide synthesis. Okay. Gabriel, when we are doing Gabriel thalamide synthesis, we cannot prepare aromatic amines. Remember that we cannot prepare aromatic amines. Okay. Because what is not there? What is the answer? What is the reason? Because this aromatic, when we are taking the halide, okay, we need to take a aliphatic halide. So if we are preparing the aromatic amine, we need to take a aromatic halide, right? So aromatic halides, they do not undergo nucleophilic substitution, okay, from the salt formed by the thalamide. So aniline. So answer is what? Answer is aniline. Okay. So this is the correct answer. Okay. Moving forward. Which aniline will not give precipitate when treated with benzene sulfonyl chloride? Okay, Priyanka has answered. What about others? Okay, Deepak have also answered. Vedvati has also answered. So Priyanka has answered it as C. Deepak has answered it as B. Vedvati has answered it as C. Okay. What is the correct answer? So, which amine will not give you precipitate when treated with benzyl sulfonyl chloride? Benzyl sulfonyl chloride is the Hinsberg reagent. Okay, it is a Hinsberg reagent. So, what it won't give? A primary amine, a secondary amine, a tertiary amine, or a quaternary amine? Okay, one more answer. Okay, Sharath. Sharath has answered it as A. Benzyl sulfonyl chloride. Okay, which amine will not give you? So benzyl sulfonyl chloride, the formula is C6H5SO2Cl. Okay, so this is your benzyl sulfonyl chloride. This is your benzyl sulfonyl chloride. Okay. So primary amine. Yes. So the answer is C. Okay, the answer is C, that is tertiary amines. Why? Because they do not have a active hydrogen. Because they do not have a active hydrogen. Okay, so the answer is what? It is a tertiary amine. So primary, secondary, okay, they react with the Hinsberg reagent, but tertiary, they do not give a precipitate because they do not contain any active hydrogen, and hence they do not react with the benzyl sulfonyl chloride. Okay. Okay. Moving forward, next question, fourth question. Ethylamine, when treated with nitrous acid, gives A. Ethyl alcohol, B. Methyl alcohol, C. Ethyl nitrous acid, and D. Ethane. Okay, Priyanka has answered it as A. Others? Ethylamine. Again, I'll write the structure of ethylamine here. So it is ethylamine is CH3, CH2, NH2, ethylamine when treated with nitrous acid, that is HNO2. Okay, what we got? We get CH3, CH2, OH. Okay, it will form a diazonium salt. Okay, then it forms a ethyl alcohol. So the answer is A. Answer is what? Answer is A. Okay, the answer is A. We have seen this. Okay, we have seen this. Yes, Vedvati have also answered it right. It is A. Good. Good. Okay, so we'll move forward. Fifth question. The product formed when aniline is treated with. So I'll draw the structure of aniline. So this is aniline. So this is your aniline. So this is a aniline. So when aniline is treated with NaNO2, that is sodium nitrate plus hydrochloric acid at 273 to 278 Kelvin, that is nothing but 0 to 5 degree Celsius. Okay, then what you get? What you get? You get what you get, students? Try to answer before I write the structure. Give the answer. Okay, Vedvati has given the answer as BDC. Yes, what is the answer? So I'll write the structure. Can you tell me what is it? Okay, Priyanka has given us C. So aniline, when it reacts with nitrous acid, okay, that is sodium nitrate and what is that? Okay, sodium nitrate and hydrochloric acid. Okay, that is it forms a nitrous acid, that is HNO2 at 0 to 5 degrees Celsius, or it is 273 to 278 Kelvin. It gives you benzene disonium chloride. Yes. Okay. She has given the short form BDC. Okay. Benzene disonium chloride. Good. Okay. So Priyanka and Vedvati have answered it right. Good. Okay. So we'll move forward. Next question. Benzene disonium chloride on hydrolysis gives. Okay. Now further, whatever the benzene disonium chloride is formed, when it undergoes hydrolysis, okay, when it undergoes hydrolysis, what it forms? What it forms further? What is the product obtained, students? What is the product obtained? When it undergoes hydrolysis, what is the product obtained? Okay, I've got one answer. Vedvati has answered it as A. What about others? So when it undergoes hydrolysis, okay, Priyanka has answered it as B. What is B? B is disonium salt. No, benzene disonium chloride. Okay, now this is what? Benzene. Okay, and this is a disonium chloride. N plus Cl minus benzonium. Benzene disonium chloride. So this benzene disonium chloride, when it undergoes hydrolysis, okay, what it forms? It gives you benzene, okay, that is benzene disonium chloride on hydrolysis gives. Okay. Okay. So the answer is A, phenol and N2. Okay. So when it undergoes, so it forms N2. That is first it forms what? Your C6H5 NH2. When it reacts with nitrous acid, it forms your phenol, okay, N2Cl. Okay. When this benzene diacetyl chloride, when it reacts with water, okay, it forms phenol plus N2 plus hydrochloric acid. HCl is formed. Okay, so it reacts with this water. That is, it undergoes hydrolysis. Fine. It undergoes what? It undergoes hydrolysis, and it will form what? It will form phenol and N2 gas is released. Fine. Okay. Next one is Hinsberg reagent is. What is Hinsberg reagent? What is Hinsberg reagent? Okay. Priyanka Vedvati has answered it as C. Okay. Benzene sulfonyl chloride. Yes, good. It is C. Benzene sulfonyl chloride. Okay. Moving forward. Next question. Carbalamine reaction is answered by carbalamine reaction. Carbalamine reaction is answered by phenols, aldehydes, primary amines, secondary amines. Priyanka has answered it as B. Vedvati has answered it as C. Carbalamine's reaction is answered by primary amines. Okay. It is for primary amines. Okay. Vinushri has also answered it as C. Yes, the answer is C. It is answered by primary amines. Good. Vedvati and Vinushri have answered it right. It is C. Okay. It is best given by primary amines. Carbalamine reaction is answered by primary amines. Okay. That is both aliphatic as well as aromatic primary amines. So if I give you a reaction, okay, CH3, CH2, NH2 plus chloroform in the presence of and base gives you CH3, CH2, NC plus 3KCl plus 3H2. Okay. So it forms a isocyanides. What it forms? It forms isocyanide is formed. Okay, so it forms a ethyl isocyanide. It forms ethyl. So carbalamine reaction is answered by primary amines as well as the secondary amines. Okay. Okay. Next question. Ninth one. Okay, ninth one. Methyl methylamine is stronger base than aniline due to minus I effect, plus I effect, plus R effect, and minus R effect. Priyanka, Vedvati, Bhagyashri has answered it as B. Okay. Others? Boys? Yes. Please answer. Methylamine is stronger base. Okay, let me write the structure. Okay, methylamine and methyl is this methylamine and is stronger base than aniline. Aniline is this. Okay, so they are saying that methylamine is stronger base than this what? Aniline. Okay, all have answered. What is answer? Let me see one more time in the chat box. Okay, all have answered it as B. That is plus side effect. So in methylamine, what is present? CH3 group is present, right? So CH3 group. So yes, so due to CH3 group, it that is the electron density is more, okay, on nitrogen atom. Okay, so you can see the electron density will increase, okay, on the nitrogen atom. So because of that, what it is electron donating group, right? This is a electron donating group, that is a methyl group. So the electron density will be increased on nitrogen. So due to plus I effect, what is that? Methylamine is a stronger base than aniline. Okay. And in this aniline, okay, what will happen? Because of the minus I effect. So your minus I, this will electron withdraw. Okay, it will withdraw the electrons, aniline. So because of minus I and R effect, what will happen? The electron density will decreases. Okay, the electron density will be decreased on the nitrogen atom. So it will be decrease on the nitrogen atom. So this is a reason why methylamines are a stronger base than the anilines. Okay, fine. Next question. IUPAC name of. So this is a compound. You can see here what is the IUPAC name of this particular compound. I'll write the structure. So NCH3, CH3, and CH3. Okay, so this is the structure. Okay, who has answered? Bhagyashree, Vedvati, Priyanka have answered it as B. All have answered it as B. It is a, okay, IUPAC name of. What is that? It is a NN dimethyl. Okay, so options are 4. A, methylamine, B, NN dimethyl methenamine, C, N-methylamine, and D, N-ethylamine. So at N, okay, so it is NN, okay, dimethyl methylamine. Yes, so NN. So at N position, there are two methyls, and this is a methenamine. So it is B. Yes, it is IUPAC name is B. Okay, moving forward, 11th question. Among the following, the strongest base in aqueous medium is. So which is the strongest base in the aqueous medium? Okay, Vedvati Priyanka has answered it as A. Among the following, the strongest base in aqueous medium is. Okay, so when I write the structure, you can see that this is CH3. Okay, CH3NH2. So this will then CH3N, CH3, CH3. Hmm. Among the following, the strongest base in aqueous medium is methylamine, NN, dimethyl methenamine. So here it will be C. The answer will be dimethylamine. Okay, dimethylamine. Dimethylamine will be the strongest base here. Okay, because you can see in this case, okay, secondary, there will be steric effect. Okay, there will be steric hindrances there. Okay, and when you are comparing this primary and this what aniline is nowhere strongest base. Now we are left with only first option and the C option. Okay, so when you see here, okay, what happens here? the combined effect of the this what the alkyl group, that is plus I effect, and this what the steric effect will be more in this case. Okay, so because of this, you can see that your secondary amine, okay, secondary amine will be strongest. So for primary and in between secondary, so secondary will be highest. So primary first will be your NH3, then will be your primary, then will be primary will be equal to this what tertiary, and this is less than your secondary amine. So secondary amine will be the strongest base. Okay, secondary amine will be the strongest base. Fine. Next one, nitration of aniline is carried out after acylation because nitration of aniline is carried out after acylation because yes, what is the answer? Acylation deactivates the NH2 group. Oxidation can be prevented. C, ortho and para products are obtained in group yield. And D, all of this. So after acylation, okay, so nitration of aniline is carried out after acylation. Yes, so acylation will deactivate the NH2 group. So NH2 group may be what? It may be highly activating group. So NH2 group is a highly activating group, and thus it will result in the reaction between the NH2 and your nitric acid. Okay. So because of that, aniline, yes, oxidation can be prevented. Ortho and para products are obtained in group yield. So all of this. Okay. So option D is correct. Option D is the correct. Next one, which of the following can exist as Zwitter ion? Para amino acetophenone, B para nitroaminobenzene, C para methylphenol, and D sulfanic acid. Which of the following can exist as Zwitter ion? Para-aminoacetophenone, para-nitroaminobenzene, para-phenyl, methylphenol, and sulfanilic acid. Which of the following can exist as Zwitter ion? Okay, Vedvati has answered it as D, sulfanic acid. So amino acids, okay, remember that amino acids will exhibit as in the form of Zwitter ion. Okay, so amino acids, how they are represented? NH2. Okay, so this is the, so it is, and also sulfanic acid. Okay, sulfanic acid also is it can exhibit as Zwitter ion. So the answer is D. Okay. Next one, the solubility of ethylamine in water is due to. The solubility of ethylamine in water is due to A, low molecular weight, B, ethyl group present in ethyl alcohol, C, formation of hydrogen bonding in water, and D, being derivative of ammonia. Ethylamine, CH3, CH2, NH2. So why the solubility in water is, it is due to Formation of hydrogen bond in water. So option number C. Okay, option number C is the right answer. Is it clear? Yes. So these were the MCQs question. Okay, so we'll see some of the 1 mark question. So we'll see one of the 1 mark question in terms of, okay, you can go through this. So among primary, secondary and tertiary amines, which amine does not react with benzyl sulfonyl chloride? So tertiary amines. So we have seen this. Tertiary amines, they do not react with what? Benzyl sulfonyl chloride. Okay, you know that. So tertiary amines, they do not react with what? Benzyl sulfonyl chloride. Okay. Now, when we are seeing the second question, that is when you are arranging the basicity. Okay, when you are arranging the basicity, when you are arranging the basicity, okay, in the increasing order of their basicity, so that is methyl amine, dimethylamine, and trimethylamine. So how you will how you will arrange the order? Yes, you will order. First will come your trimethylamine. So first will be your trimethylamine, then will be your methylamine. Okay, and then will be your dimethylamine. So when you are seeing the basicity, trimethylamine will be least. Okay, it will be the least basic because of steric hindrance. Okay, so there will be due to steric hindrance. So due to steric hindrance, it will be less basic. Then your methylamine. So methylamine will be a more basic than your trimethyl. And then the most basic will be your dimethylamine. We have seen this in the MCQs, right? We have seen this in the MCQs. So that is your trimethylamine will be the least due to steric hindrance. Okay, there will be 3 methyl groups arranged. So because of that steric hindrance, okay, so this will be least. And the most basic will be your what? It will be your this dimethylamine. Remember this, okay? Don't forget. Okay, next one. Aniline does not undergo Friedel-Crafts alkylation and acylation. What is the reason? The reason is that aniline forms salts with aluminium chloride. So when you are taking the Friedel-Crafts alkylation or acylation, what we are taking? Okay, we are taking, we are going to take aniline. Okay, we are going to take aniline, and we are going to, if you are doing alkylation, okay, it will be CH3Cl. Okay, that is a alkyl chloride. In the presence of, you are going to take AlCl3. Okay, you are going to take AlCl3. So when this aniline, okay, when we are doing alkylation, suppose, then what it will do, it will form the salt, okay, with this aluminium chloride, which is we are using as a catalyst. Okay, so here itself the aniline will form what? It will form a aniline will form a this what? A salt with aluminium chloride. Okay, it will not give you a what substituted alkyl benzene product. Okay, so you will get a salt of that. So because of that, it will not undergo Friedel-Crafts alkylation and acylation. So this is so from this chapter, IUPAC name is very important. So from all the organic chapters, okay, IUPAC names are very important. So here one structure is given. Yes, you can see the structure. Yes, so what is the structure? So the name of the structure is, okay, so at N position we have 2 methyl group. So it is NN dimethyl, okay, and methanamine. Okay, so this is a main, you are taking methane, and then amine is the suffix. Fine. Now between ammonia and methylamine, again between ammonia and methylamine, which is more basic? Okay, methylamine is more basic. Remember that methylamine is more basic. Now, can you give me the name of this? Yes. Can you give the name? So the name here, how you write here? Yes. So at N position, you have a methyl group. Okay. And your suffix will be your main chain. Okay. So it is a ethane amine. Okay. So at N position, you have methyl group. So N-methyl ethane amine. N-methyl ethane amine. Is it clear? Yes. Is it clear? So any doubts still here, students? Any doubts still here? Okay. Any doubts? If you have any doubts, please ask it in the chat box. Okay, fine. So the name reactions, okay, these name reaction, that is Hoffman bromamide degradation and carbolamine reaction, we'll see it in the next class. Okay, you can complete the following equation with the major product. So here is one equation. Okay, here is the equation R. Okay, so this is the amide group. So amide has been reacted with lithium aluminum hydride and water. Okay, what will be the product formed? What will be the product from when amide is reacted with your lithium aluminum hydride and water? You have to tell the major product. Okay, you have to tell the major product. They have not asked you minor product. They have asked you the major product. Yes, what is the answer? When your amide reacts with amide reacts with your lithium aluminum hydride and water. Okay, one answer. Yes. Vedvati has answered. What about others? Vedvati has given a correct answer. Okay. Others? So R, okay, your CH2, C double bond O is converted to CH2 group. Okay. So this is a reduction method. We are doing a reduction on amide group. Okay, on amides. So when we are doing reduction, so lithium aluminum hydride is a good reducing agent. So when we are doing reduction with lithium aluminum hydride, so your C double bond O is converted into CH2. Okay, and primary amine is formed. This is the answer. Okay, next. Next question here. Okay, so this is a another reaction wherein you have a thalamide. Okay, you have a thalamide. So this is a thalamide, C double bond O, C double bond O. Okay, then H. Okay, you react it with KOH, RX, NaOH. 1, 2, and 3. Yes. What will be the product obtained, students? What will be the product obtained here? What will be the product obtained when your thalamide? So this is a thalamide. Okay, so thalamide is taken. It is reacted with a KOH. Okay, you are reacting it with a base. Okay, sorry, halide. Okay, an alkyl halide. What will and you are reacting it with NaOH. So what will be the product obtained? Major product. They have asked you the major product. Okay, so this will be questions like this asked for 1 mark. Okay, so each reaction will be for 1 mark. So the previous 1 mark, this 1 mark. Okay, Vedvati has given an answer. Her answer is right. What about the others? Okay, try to answer. What is the answer? Yes, what is the answer? It is a primary amine. Okay, the answer is primary amine, RNH2. You have to write the structure, RNH2. Okay, the structure is RNH2. Is it clear? Okay, is it clear? So this is the expected answer. Okay, this is the expected answer. Fine. If we have some more like this, we will see. Okay. Here you can see 15th one. 15th one. This one, 15th. Complete the following equation with major products. Okay, again, we'll solve this. Aniline, when reacted with bromine water. Aniline, when it is reacted with bromine water. Aniline, when it is reacted with bromine water. What will be the product obtained? Aniline, when it is reacted with bromine water. Yes, students? Aniline. Yes, any answers? When aniline is reacted with bromine water. 2,4,6 tribromoaniline. Yes, good. Okay, you get 2,4,6 tribromoaniline. You get 2,4,6 tribromoaniline. Okay, good. Fine. Any doubts still here? So the remaining things we'll be seeing in the next class. Okay, so the name reactions, important name reactions. So that we'll see in the next class, and some more we'll see. Okay, so I'll write down the equations. You need to tell the answers. Okay, so in the next class we'll do that all things. So any doubts still here? If you have any doubts regarding today's session, you can ask me in the chat box. Any doubts? Yes, students, any doubts? Okay, fine. Fine. So I shall end the session here. Okay. So we'll meet in the next session. We'll complete the next part of Amines chapter. Okay, so till then you go to the things which all I have told, I have discussed. Please with the doubts in the next session. So thank you, dear students. I'll end the session here. We'll meet in the next week. Thank you.